Okay, we're on to our last video for chapter 4, which is all about congruent triangles. And we're going to go to what's probably going to be the most memorable, or the thing that you'll take away the most from this chapter in geometry, which is 4.4 and 4.5, which is going to be proving triangles are congruent. Okay, this is something people typically remember just because it's new, it's a little bit different, and it's kind of easy to catch on to. So we're going to draw a triangle. It doesn't really matter what it looks like. It doesn't need to be identical to this. It just needs to be a triangle. And we're going to label it A, B, C. And we're going to talk about a little bit of vocabulary real quick. So segment AB, we're going to talk about is blank angle C. And the word that goes in that blank, the word that we need to learn here, is that segment AB is opposite. Okay, AB is over here, and angle C is on the opposite side of the triangle from it. It's not part of segment AB. It's completely removed from it. It's all the way across, so it's opposite. The next thing we're going to write down is that segment AB is blank between angle A and angle B. And the word that goes in there, segment AB, right here, is included between angle A and angle B. So included is when something is between two other parts of a shape. And opposite is when something is across from or not included, at least with triangles. All right, so we'll do angle A now. We're not going to do everything. We're just going to do angles in one angle on one side. So angle A is blank from segment BC. So angle A right down here, and BC is over here. So angle A is opposite segment BC. And the last one, we'll do angle A again. Angle A is blank between AB and AC. So angle A is right here, and it is between AB and BC, so it is included. So we can have an included angle, and we can have an included side. We can have an opposite angle and an opposite side. So it's just a little bit of vocabulary before we do what we really are here to do today. There are 5 ways to prove triangles are congruent without CP-CTC. Okay, that might sound pointless to you, but CP-CTC is for when you know all the parts of the triangle, right? Then you say, well, the triangles are congruent. Well, that's great. Sometimes you don't know all the parts, though. And what we're going to do is write down 5 ways that you can know the triangles are congruent without knowing everything about all the sides and all the angles. Now, the first one, and these all have an abbreviation, is going to be SSS. And that stands for side, side, side. Okay, and the way this works is it's a theorem. So if all the sides of one triangle are congruent to all the sides of another triangle, So that was our if, right? That was our hypothesis. Then the triangles are congruent. And we're going to draw a little picture of what that looks like. So if we have two triangles where all three sides are congruent to all three sides of another triangle, then when we look at that triangle, we see an S, S, S pattern. And that is how we recognize that this is a side, side, side congruency, and we say that these two triangles are congruent. Okay, so you're looking for that SSS, all three sides the same. Our next one is SAS. You probably guessed that that stands for side, angle, side. And that theorem says that if two sides and their included angle, and we're going to start abbreviating a little. So if two sides and their included angle are congruent to two sides and included angle, then the triangles are congruent. So again, same picture. We'll draw the same kind of little triangles every time probably. And this is all about patterns and all about recognizing the pattern. So if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So this is the side, angle, side postulate. Side, angle, side. I think I said theorem a minute ago. These are all postulates. So this is the side, side, side postulate and side, angle, side postulate. Okay? Remember, postulates are things that we accept without proving it. So we're not going to prove any of this. We're just going to show you that they're true, and you're going to remember them, and we're going to learn them and move on. All right? So either one of these could be used in a proof. If you had a proof where you were trying to prove the triangles were congruent, and you could show that the three sides were congruent, then you say, okay, the triangles are congruent, and your reason is SSS or SAS. All right, so we've got three more. The next one is ASA, angle, side, angle postulate. And it says if two angles and the included side are congruent, then the triangles are congruent. Notice how I'm getting shorter and shorter with my writing. Right? We're trying to say the same stuff, but with less words. My goal is not for you to write an essay every time we take notes. It's for you to understand your notes when you look back at them. So if you can understand if two angles and included side are congruent, then the triangles are congruent. There's no reason to write all those words. It's not an English class. So there are our two triangles. I'll clean that other one up here in a second. All right, and angle, side, angle means that we have two angles congruent, just like this, and the side between them congruent. And we'll recognize that by seeing this ASA pattern somewhere in our two triangles. When we see that, we know the triangles are congruent based on the ASA postulate. All right, the next one is AAS, and that stands for angle, angle, side. And it says that if two angles and the included side are congruent, then the triangles are congruent. So, same picture, or similar picture at least. It says that if two angles, so here's the two angles, and the non-included side, so that means this side over here, right, is not between the two angles. So we're going to see an AAS pattern. Okay, so that's what we look for. We look for that AAS pattern. If we can find that, or if we can prove that, then we've proved the triangles are congruent and we don't have to do all three sides and all three angles. All right, the last one is different. This one is HL. That stands for hypotenuse leg. So if you probably guessed, hypotenuse means this is for right triangles only. It says if the hypotenuse and the leg, so if the hypotenuse and the leg of right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. We'll draw a quick picture of that. So here is our two right triangles. Here's our right angles, so we know they're right triangles. And then it says if the hypotenuse and the leg, doesn't say both, just one. So if you see that, if you see the hypotenuse and the leg, and the hypotenuse and the leg congruent, that means the triangles are congruent. You can stop proving stuff. Now, real quick, I'm going to add this note at the bottom. So real quickly, the letter combinations we didn't write down. So we did SSS, SAS, ASA, AAS, and the only things we didn't do are AAA, and SSA. And if you look SSA, that spells a bad word if you read it the other way. So this should be easy for y'all to remember. AAA does not work, and SSA does not work. So if you see those patterns, you're going to be tempted to write them down because they sound like the other ones. But just know that you can never have all A's, and you can never have this word backwards. So that'll help you remember which ones you can't have. Have a great day.